Questions from SLE number 13, which is page 43. There's no page 44. Yeah. 11. Okay. Number 11 says the absolute value of 8y minus 3 is equal to 13. So as long as we just have an absolute value, there's nothing outside the absolute value on the side the absolute value is on, we can go ahead and drop the absolute value sign and create two equations. Okay, so we're going to use this twice, the exact same way as it's written. Our first one, and then our second one, I'm going to rewrite it like this, but I'm going to make a negative sign on the side that is less yucky. So 13 is the only thing there. That is.
And this one, actually.
Not here?
Not, okay.
And yeah, okay. All right, so notice the only difference between these two is I made the most mathematical term in the world. The less yucky side, change the sign on it. Okay? So from there, we can go ahead and start solving them. I can add 3, add 3. Divide by 8, divide by 8. And then do the same thing with the other side. Add 3, add 3. 8y is equal to negative 10. Divide each side by 8. Reduce the fraction. I think 2 goes into both, so negative 5 over 4. So those are my two answers that I get. Those two answers are a certain distance away from the critical value. We didn't find the critical value, which is fine. But if I wanted to find the critical value, I just go 8y minus 3 equals 0, and then I can find the critical value. Yeah?
Do you have to simplify the negative sign?
Yeah, you just want to make it negative 5 over 4. Don't make it a mixed number. Keep it as improper. Okay? Oh, shoot. What other questions did you see? Yeah. 13. Okay, says your friend says the absolute value equation is that has two solutions. Is your friend correct? Okay, so the friend is claiming that this has two solutions to it. So the very first thing we need to do before we drop the absolute value signs is we have to get the absolute value signs alone. So whatever inside of them we'll keep there. We can stop at that point. As long as the absolute value is all by itself, we can stop there. This has no solution. The reason it has no solution is because this right here becomes a distance. I can't have a negative distance. So this has no solution to it. So the friend was incorrect saying there was two solutions. Okay? What else did you see? Yeah? 10? Okay. Number 10, I have this. Okay, absolute value is all by itself, so I can break it into two different things. So I have a over 3 equals 4. And I have a over 3 equals negative 4. So we can have the negative over here as long as we don't have absolute value signs. That's totally fine. So from there, I'm going to multiply both sides by 3. So I get a is equal to 12 is one answer. Multiply this, both sides by 3 over here. Those cancel, so a is equal to negative 12. Those are my two solutions to the problem. Anything else? Yeah. 4? Yeah. Okay, this one's only going to have one answer. And the reason it only has one answer is I don't have an x. I don't have a variable I'm solving for, okay? So I can drop the absolute value sign where that's going to go away. And then I can convert 15 over 5 just to 3. And there's our answer. Okay? So it didn't have an x to solve for, so that's why there's only one answer. Anything else? Good to go? Happy? All right, let's go to, I think it's page 45. Looks like we have two things to work out. All right. Get the absolute value alone, then solve the equation. Sounds like what we've been talking about. So problem number one, as you look at it, you might say, oh, there must not be any solution because I have this -4 there. But before we can use that terminology, we have to say, let's get the absolute value sign alone. So I'm going to do that by adding 10 to both sides first. I'll keep the absolute value sign. So if I add 10 to both sides, I'm going to get 3x plus 9 is equal to 6. Now this says, hey, we have two solutions to the problem. So I'm going to go 3x plus 9, no absolute value sign, equals 6. And 3x plus 9 is equal to -6. Solve each one. -9 minus 9. 3x is equal to -3. Divide each side by 3. So x equals -1. Second one, I'm going to subtract 9 from both sides. So I get 3x is equal to -15. Divide each side by 3. So x equals -5. So my two solutions are -1 and -5. Questions how I did that? Okay, and then the second one, let's get the absolute value alone. So it's 4 times that quantity. I'm going to divide each side by 4 first. 16 over 4 reduces to 4. Let's drop the absolute value sign. And make sure we change the sign that's less yucky to a negative sign. Change the sign that's less yucky, so it has less stuff. Make sure it's negative. Okay, I can go ahead and solve each of these. All right, -7 minus 7. Divide by 2, divide by 2. So I have that. Second one, subtract 7 on each side. Divide by 2. That does not reduce, and I don't make it a mixed number. I keep it improper. There's my two solutions. So kind of to sum up, an absolute value has a value someplace that becomes a critical value. Critical value becomes a point. Then we find the distance to the right and to the left of that critical value, that point. The critical value is not a solution to the problem. And if you ever want to find the critical value, it's not required, but you just take whatever is inside the absolute value sign, set that equal to 0, and then solve that, and that gives you your critical value. That's where your certain distance, either to the right or to the left of it. 0 is not always the critical value. Any other value can be that, okay? We good? Everybody happy? So, do you need to know what the critical value is on a problem? No. I won't ask you it. I just wanted to give you some insight. So, I'd like you to go ahead and give you a start on this, SLE number 14, which is page 4748. If you need a picture of it, I'll have my book up here so you can take a picture of the front and the back. And those of you, let me just solve this.